Alright guys, now in the trig equations that we did on Friday, we had a trig ratio and angle equal to a number. Is that right? So we had sine x equal to, can't remember what it was, 0,75 or something. Alright, so that is what we always want. We want a trig ratio. We want an angle. And then equal to a number. Okay, that is what we were looking for in the previous questions. Now, I know that this says without the use of a calculator, but if you can just quickly get your calculators out, I just want you to type in sine 40 and equals and tell me what you get from that. Sine 40, that is actually 0,64. Alright, so guys, even though it's not written, right, this equation, even though this equation is not written necessarily as a trig ratio and angle equal to a number, technically it is. Alright, sine 40 is actually a number. Right, does that make sense? If you were to type it in, sine of a specific angle, that will give you an answer. That will give you a number. Now guys, quickly do the reference angle for this. Just quickly type in, right, because that is what we would do next. We would say shift sine of this answer, right, of 0,64. Just if you type that in. Okay, so if you just typed in 0,64, this obviously was rounded off. So it's not going to give you the exact answer. But guys, the reference angle that you get from this is actually 40 degrees. So the reference angle that you're getting, right, when you use your calculator is actually that angle over there. Yes.
It is 40 if you don't have it.
Yes, yeah, exactly. If you use the answer button. Yeah, thank you. Then you get 40. Alright, so guys, what I'm trying to show you here is that instead of typing into the calculator sine 40, getting an answer, then using your calculator again to do your reference angle, shift sine of this number, you actually can already see what the reference angle is just by looking at the equation. Guys, I'm going to remind you of exponential equations. If you had 3 to the x equal to 3 to the 2, what is the x value? 2. You can just see that, right, by looking at the equation. You can see that for these two sides of the equation to be equal, x has to be equal to 2. Now, if we're looking at this equation, guys, sine x is equal to sine 40. Does it make sense that x has to be 40? Right? So, guys, when an equation is written like this, where you have sine of an angle equal to sine of another angle, so these two trig ratios have to be the same, right? Then the second angle is actually the reference angle. All right, that 40 degrees there. This is actually the reference angle, which on Friday we had to calculate it, okay, using kind of this method. But if it's just written as sine x equal to sine of an angle, we know that that angle is going to be the reference angle. Okay, so this you wouldn't write as part of your answer. You would just say reference angle is equal to 40 degrees. Just by looking at the equation. Okay, sine x equals sine 40. X has to be 40. Okay, the reference angle has to be 40. Now guys, sine 40, is this a positive or a negative ratio? Positive, right? Where is sine positive? In quadrants 1 and 2. So I'm going to have my quadrant 1 solution. What is the angle that came after sine? X. So we're going to say x is equal to, in the first quadrant, we just use the reference angle, 40 plus, what is the period of a sine graph? 360. So we say 360 degrees in, and since this is the first one that we're doing, we need to write n as an element of integers. Okay, quadrant 2. Again, x, because that is the angle that we're using, or that they've given us there. What do I do in the second quadrant? 180 minus the reference angle, so 180 minus 40, plus 360n. You don't have to write n element of z again. What is 180 minus 40? 140 plus 360n. Okay, so guys, apart from that, we didn't actually use a calculator for any of this, right? We just looked at the equation, to see that the reference angle is 40, and then we did quadrant 1, quadrant 2. Okay, let's do another one, number 2. Okay, I would like you guys to do this one on your own quickly. Cos of x minus 5 degrees is equal to cos of 30. Guys, do I have a cos? Cos equals cos. Yes. So what is my reference angle going to be? 30 degrees. What is the angle that you're going to write in your quadrant, whatever's, your solutions? X minus 5. Okay. Do that one on your own, please. Alright, guys, so we have cos, and this is positive cos, right? So we're working in the quadrants where cos is positive. So that's 1 and 4. The reference angle is 30 degrees. So for quadrant 1, we say that angle, x minus 5, equal to the reference angle plus 360n. And then we must add 5 to the other side. For the fourth quadrant solution, remember we say x minus 5, that angle, equals 360 minus the reference angle. So that will give us 330, and then we have to add 5 degrees again. Okay, you can copy down the next one so long. I'm going to do the next one with you guys. Alright, now this one is a little bit different because now on the right we don't have cos of a number. Right, so even if you try to type this into the calculator, you couldn't because it's cos of 2x. But guys, we still have cos equals cos. So now in this case, our reference angle is going to be 2x, which is a bit strange, alright, but I'll show you how we're going to work with that. This angle is going to be our reference angle. In order for this equation to be true, in order for this side to be equal to that side, our angle must be equal to that angle, 2x. Okay. This still is positive, guys. I know we don't know what x is, but there's a plus in front of that cos. Alright, if it was negative, there would literally be a minus in front there. We can do an example like that just now. But again, where is cos positive? In 1 and 4. And I'm also just going to write here, reference angle is 2x. So in quadrant 1, we're going to have this angle, x plus 15, equal to 2x plus 360n. So I'm not going to write it again because I have written it up at the top. But you can. Okay, if you want to write it every time. Now, guys, we need to solve for x, right? So we need to get all the x's on the one side and everything else on the other side. So I have an x here. This plus or this positive 2x, when I move it, it's going to become minus 2x. So what's x minus 2x? Negative x. And this plus 15, when I move it, is going to become negative 15. Still plus 360n. Please, you have to write that every single time. Now, what must I do to get rid of that minus 1? Divide by negative 1. Okay, good. So we can say x is equal to positive 15. Now, guys, for the plus 360n, you can actually leave it as a plus, or you can change it to minus 360n. It's up to you. The 360n is almost like a variable because you're going to sub in different values for n, so it doesn't matter. But if you're worried that you're going to get confused, rather just change all the signs. Okay, I think that's what we did last year. When you're dividing by negative 1, you can divide all of them by negative 1. Okay, that's the quadrant 1 solution. Quadrant 4, we're going to say the angle that was after the cos in our original equation, so x plus 15, is equal to quadrant 4, we do 360 minus the reference angle, which is 2x. Plus 360n. Now we must again get all our x's on the one side. We have x, and then this minus 2x is going to become plus 2x. So we're going to get a 3x equal to 360 minus 15. That's 345, hey? 345 plus 360n. And now we must divide everything by 3. What's 345 divided by 3? 115. 115 plus 120 in, like that.